We'll have you start your stream first, right? Good. All right. And is it picking up? No, oh, I'll just talk. Okay. All right. And how about there's no microphone? Okay. All right. Yeah, folks. Yeah. Is everybody ready? Is you talking? Yeah. Hello. Would you like? Is everybody good? Let's start, right? Yeah, we're already a bit delayed. So, okay. So, welcome everybody to CJUG. I know we have a small but very cozy group, and so feel free. I think it's a very kind of flexible time. So, welcome to Chicago Java Users Group. Today's meetup is with Sean and Sean Sullivan talking about Netty in the real world. Let me keep going here. First of all, we have raffles. We have 2 JetBrains licenses for raffling. So if you'd like to, please scan this and make sure you haven't won anything within the past 9 months, because that means you won't be eligible. And also, just a note to later in the slides too. Oops, let me hold on a second. I think I. And, I think I was actually connected to the YouTube at the same time for testing. So, okay. So later too, I'll be talking about there's a Chicago Postgres Day next week, and they're giving out 2 free tickets. So, and then on this form is asking you if you're going to the Postgres Day. If you are, then you'll be eligible for entering into the drawing too. However, if there are only 2 people showing up, then the 2 people will get these 2 free tickets. So I just want to mention it here. So. Okay, so just some housekeeping. We have Chicago Tech Slack. If you haven't already joined it, please join. It's kind of more than 11,000 subscribers now. Most of them are based in Chicago, but otherwise, some of them too are from outside, which is nice. You can have friends and talk about things. And then there's Java Off Heap, and one of the stars from there, the original Bob Pollin, is one of the Java Off Heap members, and they are continuing with this podcast with Freddie Gimay and Mike Minella and Josh Juno. So, and this is our meetup.com link and there. And actually, we also finally fixed up our website, so you can visit cjug.org, and it's really at the credit of Josh Austin, who helped us revamp that site. So thank you. Yeah. So we're working on that. So, and also please follow us on X or Twitter if you haven't already done so. This is our @CJUG handle. We are also on Discord if you haven't already joined us, but I think most of the folks are already there. If not, please join this room if you like to continue conversation about Netty with Sean on this room here that's listed down there. Community info. So we are community partner with JetBrains, who has been generously donating their complimentary licenses, 2 licenses per month, and also other things too. And then I mentioned about Chicago PG Day. That's the Postgres community conference next Friday. So if you're a Postgres person and or interested in it, there will be 2 free tickets that will be given out by Chicago PG Day to CJUG as a community partner. So you can indicate on that form too if you're going, then you can claim that ticket if there are not more than 2 people claiming. And we are also community partner with JCon, that's based in Cologne, Germany, which will happen in May. And they give out free tickets to all JUG members all over the world, if you'll be in Germany. And then we also are member of the devitjobs.us. They are a site that have a lot of community information and also job search all over the world. Also, we are community partner with We Are Developers. They are a big 30,000 conference based in Berlin every year. And then also CoMotion Madrid too. If you're interested, they are offering some discount code too if you're interested too. So these are like next few pages just talking about the links to the Chicago PG Day 2024. That's the link, and tickets price are regular. They are 150 each. So like I said, there are 2 free admission tickets. And then JCon Europe, this is the link, and also free admissions for JUG members. And then CoMotion Madrid too, their special code until May 19th for partner_chi. Upcoming events, May meetup, we're still planning for that right now. And then June 20th will be Billy Corando from the KC JUG group, and also he's a Java developer advocate at Oracle. He'll be talking about Java 22. Then in July, there will be Celebrity consulting firm that's based in Ohio. The CTO, James Carmen, who is also an Apache PMC for Camel and Commons, he'll be coming here to give a talk too, and that will be in July. And then other confirmed speakers. And in fact, today, Venkat already sent me a couple of dates. So Venkat will be here for, I think he would like to come in October, but we're trying to see if we can, get things set up for him. If so, it would be October 21st that week too, just to give you a heads up. And then Alina Yurenko, who's based now in Switzerland, she's otherwise based in Ukraine, and she is the Grau VM expert. I'm still trying to schedule something with her to talk about Grau. And also Josie Pomalt from Oracle too. He's also interested in speaking for us. So stay tuned. We're trying to find some dates, and these will be virtual meetups too with them. And we're still planning for a meetup to a conference style meetup if you're interested.
I cannot wait until people say my first name.
The first thing?
That's my life goal.
Yeah. There's something else.
Everybody,
oh, Venkat is a trademark. Venkat, I know. Yeah. Now, if you're interested in speaking at CJUG, please send your proposals to present@cjug.org. So feel free to, if you have some ideas and just want to bounce off ideas, feel free to connect with us. We can talk. For job seekers and recruiters, this is our CJUG group on LinkedIn, where you can connect with one another. And then if you would anybody, I think this is a small group, would anybody would like to share your story, or if you're looking for project collaborators or looking for people to join your team, or maybe you're a job recruiter, but it doesn't look like anybody is recruiter who's hiring. But anyway, this otherwise too would be a time for you to share your story. But if not, we can always talk about this afterwards too. So, all right. And here, just some recognizing some sponsors. Past sponsor, JFrog. Unfortunately, they can't sponsor anymore. And then Fusion off as well, previous year. And then want to announce, kind of pre-announce, they will be signing at Aiden, their payment company that's based in Netherlands, but they also have a big, kind of relatively big development group in Chicago too. So they actually indicated they're asking us, to sign like some sort of contract to become our gold sponsor for this year. So that's a good news. So. Okay, friends of CJUG. These are, we are friends with all the worldwide JUG community, with Portland JUG, for example. And then the ones that were really good friends with us are like, we're kind of really like, cousins. Felt like Atlanta JUG and Boston Java user ACM chapter of New England, Garden State JUG, New Jersey, Kansas City JUG, Missouri, New York Java SIG, the oldest JUG in the US, and then Pittsburgh JUG too. So please visit their sites. They are also having like virtual meetups too. So. And here, now speaker today, just want to introduce Sean Sullivan from Oregon, and he's a software engineer with very deep experience in building Java apps over 20 years. He previously led platform teams at different major companies like Netflix and Twilio, and then he's also a JUG leader of the Portland Java Users Group. So with that, I'll hand over the stage to Sean. So welcome, Sean.
Thank you.
Okay. Yeah.
In the form, we have two options when you plan to attend. So if you want to register for the free tickets, we have to say yes.
All right. Well, good evening. I'm Sean, and hopefully we'll have an interesting talk about Netty tonight. So first, I'll just want to thank Microsoft for hosting the event. This is a great venue. Really appreciate it. So I guess tonight we're going to talk about Netty, but I'm just going to share some stories of like things I've worked on, like code I've written, things that like intersect with the Netty project. And this is not going to be a tutorial of Netty. Like a Netty tutorial would probably take more than an hour. So I'm not even going to try to do a tutorial around Netty. But I'll just share some stories about like things I've worked on and show some code along the way. So I live in Portland. Been attending Java user group meetings in Portland since the beginning. the Portland Jug started in 1997. It's been active throughout, and still going strong. Recently tried to stay active with some open source work and kind of highlight that here. But in terms of Netty, I'm not like a core contributor to the project, but I've fixed a bug, Netty. So this was a year or two ago. There was a problem with HTTP compression in Netty, and when I was working on a project at Netflix, and we needed to do compression of HTTP responses. So we tried enabling broadly. Turns out there was like an edge case that was not working so well. We were able to get it fixed and get it merged. So I guess that's probably my biggest contribution to the Netty ecosystem. What else? So I've also contributed to some open source projects that are Netty adjacent. So all four of the things listed here, these all use Netty underneath. So Netty is a building block for other libraries and frameworks. And we'll dive into some of these in a bit. But like anything else, Netty is open source. And Netty is sort of a standalone project. It's not part of any sort of open source foundation. You know, like many open source projects, it seems to be self-managing, and it seems to be doing really well. The Netty project typically has a monthly release. That's the typical cadence. There was actually just a Netty release 2 days ago on Monday. Anyway, very active community. They have a Discord group as well. Good place to like tap into the core developers. So I was a platform engineer at Netflix, and I worked on the cloud gateway team. The cloud gateway team at Netflix was responsible for basically owned and operated Zuul. Zuul is Netflix cloud gateway. It's open source. You can find it github.com/Netflix/Zuul. And that's what Netflix runs in production. It's a mission critical system. It's considered basically like tier 0. It has to be online all the time. It handles hundreds of billions of requests. And so our team runs Zuul, which uses Netty as a foundation. But Netty tends to show up in other places throughout the Java ecosystem. In fact, if you're running Cassandra at your company, Netty is part of Cassandra as well. So you'll find Netty in far more places than you expect. So the Zuul code, if you're digging around on GitHub, and you're curious, like how does Netflix use Netty in the cloud gateway? It's in this module called Zuul core, and then within that module, there's a Java package, which is basically the Zuul Netty server code. And typically, if you look at any application that's built on top of Netty, you'll typically find this import in almost every case. It includes the Netty server bootstrap class. And basically, if you have like any application with like a main method, your main method will set up a server, which will involve something that looks like this. You instantiate server bootstrap, and then there's a bunch of options after that. And as an application is starting up, one of the things that it needs to do is initialize Netty's channel pipeline. This code is actually from the Zuul open source repo. This is how Zuul initializes a channel. And when you're initializing a cloud gateway, there's different concerns that a cloud gateway has. For example, these are the channel handlers in Zuul. The one on top is for handling timeouts, and that's fairly important if you're handling billions of requests. You register these channel handlers with Netty. And then in the bottom section here, that's an example of SSL handlers. And so in Zuul, there might be some secure connections. And so you might be interested in the SSL handshake information. And you might also be interested in handling SSL exceptions. So this is an example of, harnessing Netty's channel pipeline and registering, custom functionality into a channel pipeline. But Zuul does more than just processing REST requests. I mean, historically, people think of Zuul as just, okay, there's the HTTP GET, HTTP POST, runs through Zuul, and Zuul does some processing. But Zuul is more than that. Zuul also supports push messaging. And there's a very clear use case at Netflix. So like if you have a smart TV at home in your living room, you probably have some Netflix app running on that smart TV. And, Netflix wants to push information to that app. It could just be a message to display to the user, or it could be some other catalog information. But ultimately, Zuul provides a mechanism for broadcasting messages out to all these smart TV devices in the Netflix ecosystem. So there was this tech talk in 2018. This was at AWS reInvent. And it kind of talks about the motivation for supporting push messaging in Zuul, and it leverages Netty underneath. And so you can actually find some of this code in the Netflix Zuul GitHub repo. There's a class called push protocol, or an enum push protocol. And the code, I've oversimplified it here, but this is actually actual code from GitHub. But ultimately, there's a method called send push message, and this is using Netty functionality to basically send data over a WebSocket to the smart TVs that have established WebSocket connections. And so if you look at the top here, there's two import statements. So we're importing from io.netty. And we're utilizing a sub package called the WebSocket X. And within Netty, you have a class called the text WebSocket frame. So you can encode information into that, and then Netty can write that out onto the network and send it down to those devices. And I also just want to mention, since I had Cassandra on an earlier diagram, if you go to GitHub and look at the Cassandra project, you'll find that sure enough, Cassandra is also using server bootstrap, just like Zuul. So any sort of application, be it a database or a cloud gateway, or anything else, if that application wants to listen for connections, it's going to set up the server bootstrap. So that's fundamentally, if you're interested in a deep dive into Cassandra, go find the server bootstrap class in the Cassandra repo, and that kind of shows you how they initialize Cassandra, or at least initialize Netty. So I like to think of Netty as sort of a general purpose network application framework. It's sort of protocol agnostic. It allows you to plug in a custom network protocol if you had something custom. But it also provides you with codecs for standard protocols. So like if you want to do HTTP 1 or HTTP 2, those codecs are also available, and you can kind of utilize them if your application needs that. I like to think of Netty as sort of like this building block that you don't need to think about too much, because largely you're using Netty is like a low-level framework. And most application developers are going to be using higher level frameworks. And they don't need to touch Netty directly, but you kind of need to know that it's there. And if you ever have like a production bug, sometimes you need to go look at Netty and see what it's doing. And in the Apache Foundation ecosystem, there's a ton of projects that are built with Netty as a building block. So like Camel, for example, runs on top of Netty, Cassandra, and another slide here, you'll find Flink, Nefi, Pinot, Pulsar, Spark, Zookeeper. They're all using Netty in one way or another to listen for connections. So, and I was trying to figure out, like, beyond the Apache ecosystem, what else is using Netty. There's the Armeria framework, which was written by Trustin Lee, who was the original author of Netty. So he's now working on a higher level framework. There's Micronaut, which is seems to have some traction in the industry. That's built with Netty. Zuul, as I showed. And then there's OpenSearch. This is the fork of the Elastic Search project. So OpenSearch makes use of Netty underneath. There's a bunch of other things in the ecosystem as well. If you're using the Microsoft Azure SDK for Java, that is, a client library to connect to Azure services, but it's using Netty as a way to establish those connections to those cloud services. So all that code's open source. You can find it under Microsoft's Azure SDK for Java. But it's very pervasive. So I like to think of, Netty is like everywhere. And largely it just works and you don't need to think about it too much. So why is Netty popular? And it really comes down to like network IO. The reason Netty exists is to do non-blocking IO. And it's really good for building scalable services. And so that, I think, is like, that's the core purpose of Netty, is to make sure that you're building applications and systems that are very scalable. And at Netflix, our cloud gateway was dealing with hundreds of billions of requests. So I'd say Netty performed really well with that. Now, if you look back at where Java started, like way back in like 1996, JDK 1.0 gave you the java.net package. And in that package, you've got like a socket class and a server socket class. And I think when I wrote my first Java application, I think I was like playing around with server sockets. And the thing about this is, this is all a model of blocking IO. And so I think Sun or Oracle now realized that the blocking IO wasn't working so well. So over time, since Java 1.4, the JDK has given you a better option. The Java NIO is really the successor. And this is sort of the next generation, at least in the Java 1.4 world. You can build a server with this. But I would like to say that like Netty goes far beyond NIO. And so that's why like Netty has been widely adopted, is because it gives you more capabilities beyond just NIO sockets. So at its core, Netty has this abstraction, which is called a channel. So a Netty channel kind of think of it as an abstraction over an actual socket connection. But with a channel, there are certain operations that you can perform on it. You can read and write data to a channel. You can connect and bind as well. So typically, like the Zuul Cloud Gateway, we were dealing with the channel abstraction. And the way that you handle channels is that you have these other abstractions in Netty, such as the channel pipeline. And a channel pipeline is really a list of channel handlers. And channel handlers are just a way to encapsulate. It's a class. Well, this is like an interface, and then you can have an inbound connection handler and an outbound connection handler. And then you can use those to implement some logic. So there are some built-in handlers provided in Netty, and then you can also implement your own custom handlers as well. Another core concept with Netty is byte buff. Byte buff is really a sequence of bytes. So it's a Java object that's an abstraction over a sequence of bytes. And what's interesting about byte buffs is that so one of the goals of Netty was to be as performant as possible. So in Netty 4, which is the current, Netty 4.x is the current production release. There's this implementation of buffer pool. So as your application's running, you're allocating these byte buffs that are managed by this buffer pool. And the Netty team kind of introduced this buffer pool concept really to reduce the overhead of garbage collection. You don't want to if you're trying to scale to 10 billion requests, you want to minimize the number of object allocations you have on the heap. And so, the Netty team figured out ways to do this optimally. I'm kind of like skipping over like the details here because we only have an hour tonight. But these are like the core ideas. Is that, if you're using less memory, Netty applications can scale better. And so one of the ways that Netty tries to go beyond the JDK in functionality is that it uses a lot of native code. And so if you look at the Netty code on GitHub, you'll find that it's a combination of Java code and C code. And there's a fair amount of C code in the repo. And I can say that as a person that's used Netty for a couple of years, like I've never touched the C code. That's kind of just owned by the core team. But you do need to be aware that it's there, because when you're deploying a Java app, your class path is going to have a bunch of jars, and some of those jars are going to have native code embedded in the jars. And if you're deploying to like an x86 box, well, make sure you're deploying the right jars that have the x86 native code. And if you're deploying to like Graviton or I don't know, something else, you want to make sure you've included the appropriate native code jars as well. So in the Netty world, there's this concept of like transports, and there's different implementations in Netty about how how you read and write data fundamentally. So there's these native transports that are considered optional. I mean, you could write a Netty application and you don't have to use the native transports. But if you're trying to scale to like a huge number of requests, huge number of connections, it's generally better to run a native transport. So ePOL is a native transport for Linux. IOUring is also a Linux transport, and then KQ is for BSD, so it's like Mac OS. So in fact, at Netflix, the Cloud Gateway, and you can see this in the open source repo, the Cloud Gateway uses the ePOL native transport for Netty. And this philosophy of having native code with Netty apps is something you need to kind of think about when you're setting up your class path and so forth. You generally will want to pick, a transport, one of the native transports on the left, and then you also have to make decisions about how, like, is there other functionality that you need? So like if you're a cloud gateway, you might need to handle SSL connections, TLS. And Netty gives you a native implementation of SSL, and it's called the TC native boring SSL library. Who knows the history of like boring SSL? So boring SSL is from Google, actually, and it's a fork of the original Open SSL library. And so Google, wanted to do their own SSL library to support Chrome browser. And so that's kind of where the genesis of boring SSL. And then there was basically this Java wrapper around boring SSL. And I believe Twitter was involved in setting up that wrapper. And then they ultimately donated the code to the Netty team. And so now the Netty team owns TC native boring SSL, which is a Java library. But if you add it to your class path, Netty will auto detect it and will start using it. If it's not on the class path, Netty will still run, and it will just use the JDK implementation of SSL. So if you look at like the Zuul repo from Netflix, you'll see that the TC native boring SSL is part of that application. It's more performant. It generates less garbage on the heap. So essentially it will scale better. And then there's two other libraries I listed here that are totally optional, but they can be useful. Brotli for J, Java library that does Brotli compression. And then ZSTD is Z standard. Z standard is another compression algorithm. And so if those libraries are present on your application class path, Netty can take advantage of them. But if you don't put them on your class path, Netty won't even attempt to load them. Well, Netty will detect that they're not present, and Netty can keep operating without it. So I mentioned one of the native transports is this IOU ring. This is considered an incubator library. It's not really, hasn't really been promoted to the main Netty repo. And I was curious about this about 2 years ago. Before Netflix, I was working for Twilio, and at Twilio, we were running Zuul as the production cloud gateway at Twilio, and we had a hackathon week while I was there, and I spent the hackathon week like looking at this library, and then I was trying to figure out, okay, how can I make this library work in Zuul? And I was able to make some changes to the Zuul repo. So now that Zuul now has the ability to use IOU ring instead of ePOL, although by default it'll just go to ePOL. You actually have to explicitly set like some configuration to force this transport to run. But the PR got merged, and it's kind of interesting to look at because it shows how like Zuul supports more than one transport type. All right. So at Netflix, one of the things the Cloud Gateway team is responsible for is compressing responses that we're sending. And so we rely on Netty to do that. And Netty actually supports multiple compression types. And by default, like gzip is like enabled in the system. Netty can return gzip compressed content. But we had a use case where we were like wanting to look at Brotli as an alternative for compression. And Brotli was invented at Google, as I understand, and it's, I think, adopted in almost all the browsers now do Brotli responses, Brotli decompression. So they'll send an accept encoding header to a server, and if the server knows how to handle Brotli, it'll compress in Brotli and then send it down to the browser. So I was on a project where we were looking at Brotli. And so it's actually not hard to get it working. I mean, we found a bug, but that's now behind us. But there's this class in Netty called the HTTP content compressor. And if you want Netty to compress your responses, you have to explicitly add the compressor into your channel pipeline. And so fairly straightforward. If you look at the Zuul open source repo, there's actually like some integration tests that verify that it works. So, with a cloud gateway, you want to ensure that you're getting valid responses back. So these tests are like, it sets up an HTTP GET, puts a header on there called the accept encoding header, and then it asks the server to do a gzip encode, and then the response comes back in the encoded format, and then we manually like decompress it and then verify that it's what we were expecting. So there's two tests in there now, because I wanted to ensure that the Brotli code always works from this day forward. Once the Netty team merged the Brotli fix, at that point I knew that this test started to pass. So working with Netty, you'll always encounter different surprises. I guess I'll call them pitfalls, but it's like any other Java framework. The first time you hit these pitfalls, they're painful, but you kind of learn the lesson and continue on. So one of the things, this is somewhat surprising about the Netty code. There's actually two different classes for cookies. I think these are interfaces, but the top one is deprecated. It's like fully deprecated. They deprecate the interface and they deprecate each individual method in the interface. And then the bottom one is the one you should use. It turns out the Netflix Zuul code was using the wrong cookie interface for a while, like for the last 7 years. But recently, I think in the last 2 or 3 months, switched over to the correct cookie implementation. Another pitfall that I kind of learned accidentally was that the content compressor has multiple constructors, and if you invoke the one on top, it doesn't do what I wanted. It's sort of like that was the original constructor, and it had some legacy behavior, and then over time they're like, oh, we want to support more than gzip, and we're gonna have to define this thing called compressor options. And so now there's like this second constructor, and this is actually the one that you should use if you're wanting to do like Brotli compression or Z standard compression. It initializes the compressor differently. It has very different initialization logic. So yeah.
How did you find out, right? Was it just accidentally? Was there any major bug or something?
Yeah. So in the Netty's repo, they have like some example apps. And I looked at one of the example apps because I was trying to find an example of Brotli compression. And I ended up, I don't know, I found like this line of code in one of their examples, but they don't use that constructor in all of the examples. There's some examples that are still, I think, still calling the top constructor. So anyway, ultimately I was like setting breakpoints and like stuffing through code. And then I realized like these two constructors are very different, and the top one does not call the second one, and the second one does not call the first one. It's just different initialization logic. Oh, and this was an interesting little pitfall. This happened last September. So at Netflix, the Cloud Gateway team was looking at Java 21. When did Java 21 come out? September last year? Okay. So we wanted to test it out. So we like set up a canary, and we deployed our Cloud Gateway on Java 21. And anyway, we found out that the canary died. You know, that's what canaries are for, I guess, in the software world. But the Java process actually exited, and it was like the whole thing aborted. So our canary was no longer like listening for connections. And the day, I think within a day or two after we found this, the Netty team sent out a tweet, and they're like, "Oh, there's a problem with Java 21 and Netty." And then they like fixed it, I think within like 72 hours. Once they were aware of it, they immediately put out a new release of Netty. And the bug only showed up if you were running on Linux and you had to have the epoll transport enabled. And that's where things went sideways. If you were not using epoll, you probably might not have seen this, but this was a tweet from September 28th. This is the Netty team announcing the emergency release. And so this was the bug fix to ensure that Netty could run properly on Java 21. So I was very excited when this went out. We immediately pulled in this new version. We redeployed our canary. It turned out this worked. This was stable for us. And then probably like about a week later, we put Java 21 in production. We were very aggressive, probably the most aggressive team at Netflix going to Java 21. Yeah, this was like the only real showstopper, was that if you happen to be on Netty 4.1.98, it was or before, it was, you were gonna have a bad day. But once you get to 0.99 and above, it works. All right, another pitfall that you may encounter with Netty is this thing about resource leaks. So in Netty, some of the objects are reference counted objects, which means that you may have to think about deallocating objects or decrementing a reference count. And this is counterintuitive. Java developers don't. We use garbage collection. We don't think about like reference counts. If I instantiate a string, I don't know what the reference count on it is because it's not my job to track it. It's the Java VM tracks the references. But in Netty, this is very different. So because Netty uses like, you know, off heap memory, and you've got this byte buff data structure, you might run into a problem where you've maybe allocated a bunch of objects and they never got freed, essentially, or they never got returned to a pool or things of that nature. So the Netty wiki has like this whole article about reference counted objects, and it kind of explains why it exists. It's really about performance. Netty is trying to squeeze out a lot of performance, and so it sacrifices, the developer experience for performance, and that's sort of an explicit trade-off in the framework. If you look at this document, it talks about, Netty version 4 kind of made this the standard programming model. And so there are reference counts for these objects, and then, you want to return objects to an object pool, because under the covers, Netty pools certain objects. So in the Netty documentation, they basically admit this. The disadvantage of reference counting is that it's easy to leak these objects, and that makes sense. Especially if you're a Java developer, you probably don't think about like deallocating resources all that much. However, I would argue that like there are resources in Java that you do need to manage. Like a JDBC connection, you need to call a close method, and hopefully it's now auto closable. But still, like if you didn't close a JDBC connection, you could have a bug in your app. Or if you had like an input stream, if you're reading from the file system in Java, you have an input stream. What if you forgot to close your input streams? Well, that's a resource that you forgot to release. And so this is kind of similar in that regard. But your app might be running happily this week, and then maybe there's a leak that you didn't notice, and then all of a sudden the leak causes things to go upside down. And debugging a resource leak can be tedious, especially if it's not your code. Like sometimes these leaks show up in places you don't expect. Maybe the code's been running fine for 3 or 4 years, and maybe the developer who wrote it has left the building, and you now own the code, and now you have to like think about like, oh, how do I debug this code that I'm not familiar with? There's this great tech talk on YouTube about Netflix Zuul 2.0. This talk was from 2017. This was in St. Louis. And the speaker was Arthur. I used to work with him. And in his presentation, he talks about the pain of putting Zuul 2.0 in production, in that often the servers would like run out of memory and then stop serving traffic. And these were hard problems in those days, hard to debug. Luckily, Netty does try to help you. Tries to help you by giving you this thing called the leak detector. And the leak detector, will like print out a log message saying, oh, I think there might be a leak. And so that can sort of like give you a heads up that like, oh, there could be an issue here in production. You start seeing the word leak appearing in your logs. And so if Netty is like sending you this warning message in your logs that there's some leaks going on, you can try like the more advanced detector levels, which gives you more granularity, more detail about like where the leak might be. So Netty tries to like help you find the leak. And there's this special mode called paranoid mode. But there's a disclaimer in the Java docs, and it says like, oh, like paranoid mode is going to slow down your application, because it's causing the leak detector to do a lot more work. And so paranoid mode is not recommended for production use. So, as you're debugging if you could reproduce it locally, that'd be great. Then you could run like paranoid mode in your local test if you had a way to reproduce a bug. So there's this idea, this is straight from the Netty wiki, that they kind of suggest that when you're running your unit tests and your integration test suite, turn on paranoid mode, and it'll slow down your unit tests and it'll slow down your integration tests. But it's better than having a leak in production. And so the general idea is, if you set a JVM system property and you tell Netty, I want paranoid mode on, then when your test suite runs, it'll be aggressively looking for leaks. So I had this idea. I was like, oh, Zuul has a test suite. We run it on every PR. Wouldn't it be nice if we set up paranoid leak detection in our test suite? And so you can see this is in the Zuul open source repo. I wrote this class called the custom leak detector. It extends some other class, but that's not important here. But I wanted to define my own leak detector logic, but I'm extending something else that was providing most of the functionality. And then, so ultimately, I was keeping track of anytime a leak was reported by Netty, I stuffed it into this thing I call the global registry. I regret that name, but it's like the leak registry, I guess, is really what it is. But and then I added this helper method called assert zero leaks, and it will check my registry to see if anything was detected. So there's like this thing called the leak counter, and I'm checking all the leak counters and checking whether or not it's greater than 0. So if leaks are present, this assertion should fail in the test suite. And so if you look on GitHub, you'll see this code. It's called integration tests.java. When the test starts up, it explicitly sets a system property. This might be bad practice, but it worked. It installs my custom leak detector, and then Netty will see this property, and then Netty will utilize this custom code. And then when the integration test is done, it's basically JUnit 5. So there's a JUnit 5 annotation called after all, and this executes at the end of the integration test, and I call assert zero leaks, which is a static method, and this tells me, did we find anything while this integration test was running? And so it's fairly good. I mean, it's not going to catch like all problems because our integration test doesn't really test all the scenarios. But it's a baseline check just to make sure there's no regressions, more or less. So recently I was thinking, well, why can't I just generalize that code and just make it a JUnit extension? And so that's what I did. There's now an open source project on GitHub called the Netty Leak Detector JUnit extension, which is very Googleable. I figured someone would be Googling those words, so that's what I call the library. This library has been available for probably, I don't know, 2 months now. And it's basically a similar concept as what I showed earlier, but this repo only has 2 classes in it, 2 source files. There's the JUnit 5 extension class, and then there's this other thing called the leak listener class. Here's how you would use it if you needed it. Oh, that's actually, there's a bug on this slide. Does anyone see it? Yes. Yes, this needs to be scope test. Yeah. This is not a jar you want on your runtime class path. This should only be on the class path for tests. So that's a mistake there. All right, but here's how you use it. It's like any other JUnit extension. You just use the annotation extend with and the class name. And that activates the extension for that test file, basically. Internally, this is really what's happening. It's instantiating something called a leak listener object. Netty, this method called set leak listener, this is relatively new. This was only added to the Netty API probably in the last 6 months. So set leak listener is how you register for, you want to know about any leaks that are happening. So I've registered my own object, and then I internally have my own assertion method. So I've actually merged the extension into some other projects out there. So async HTTP client library now uses the extension as of like 6 weeks ago. And then Reactor Netty has an open PR. It's still in draft status, and it's not really ready to merge yet, but it's pretty close. I'm hoping to get this finished soon. But anyway, so it has limited adoption. All right, so I want to talk about another little thing I've been working on, Apache Pinot. This is the Apache Software Foundation. Pinot is like a big data system for real-time analytics. So Pinot uses Netty under the hood. And Pinot, imports, the Netty BOM, and Pinot has a class called the query server, and just like Zuul and just like Cassandra, this server initializes a Netty server bootstrap. And that's how you know it's a Netty class that's going to listen for connections, basically. And while I was working on Pinot, I thought to myself, oh, it'd be great to have leak detection in Pinot. And I wanted to plug in my library here, but it didn't work because Pinot doesn't use JUnit. Pinot uses testng. But that was fine. I came up with a different solution here that worked with testng. Testng has some callbacks, and you can basically do a similar thing. So Pinot, every time you run the build suite, the entire test suite, it's using Netty detection here, leak detection. And here's another pull request. This is still in draft status on Pinot. I opened this because I wanted the Netty transports, the native transports, to be enabled by default. Pinot supports native transports, but only if you explicitly put it in a config file that says native transports equals true. And so if you don't put that config in there, then it just runs on vanilla Netty without like the fancy native epoll. So I was trying to open a discussion to see if we could get just this native transports. It will just auto detect if the epoll libraries on your class path use it. So it remains to be seen if this gets merged. I'm not sure where that's going next, but do you want to talk about security briefly? So last October, there was this massive denial of service attack on the internet. It kind of started like last August. And then there was a public disclosure of this problem in October. It was called Rapid Reset. And so Cloudflare has a whole write-up on their blog. I'm not gonna like go into the esoteric details, but suffice it to say, it was a massive concern at basically all the big tech companies. So like Amazon, AWS, Microsoft, Google, Cloudflare, all these players were very concerned about this vulnerability, which was, sort of a weakness in the HTTP2 protocol. And there were people on some rogue actors who were trying to exploit it against Cloudflare and other players. And so this was also a concern at Netflix. We were discussing this last September. And the Netty team ended up coming up with a mitigation in the Netty framework. So if you're using HTTP, if you have HTTP2 enabled in a Netty app, it's recommended that you start running version 4.1.100 or higher. If you're running older releases, you may be vulnerable. So when this came out, we at Netflix, we immediately upgraded and rolled it out. So I know we probably have some Spring developers in the room. Anyone using Spring? All right, yeah, Spring's everywhere. It was like the default framework at Netflix, in fact. But Spring Boot gives you a couple different implementations of web servers. There's like a web server interface in Spring, and then there's like 4 implementations in the Spring Boot repo. I don't know which of these is popular or more or less popular, but you do have the option. You can use Netty as the underlying implementation of the Spring Boot web server. And if you want to like go down that path, this is like how you would get started with that. You'd use Spring Boot Starter Webflux, and that would pull in the Netty web server. And I was like playing around with this recently. So I built like a Hello World app that uses the Netty web server underneath. I set some breakpoints and watched it execute because I wanted to see like what Spring Boot was doing with Netty. And it turns out that like Spring Boot is using the Reactor Netty library, and the Reactor Netty library is doing all this Netty stuff. So that's the gist of it. So I'm going to wrap up here by saying there's other really good resources for learning Netty. There's an awesome book from Norman Maurer. He's like the core leader of the Netty project. And this book, it's from 2015, but it does cover Netty 4, which is the current, like Netty 4 is what everybody's running. And so this is like a super good book for learning like the technical details about like some of the internal things about Netty. And then there have been some other conference tech talks. This is from last October in Belgium. There was a Netty talk, and the speaker here is Stefan. He works on Gatling, the load testing tool, and Gatling uses Netty to do its connections. So this talk is really excellent. It goes into a lot more detail than what I've done tonight. And then also at the same conference in October 2023 was this presentation from Trustin Lee. And Trustin is the one who invented Netty. He's the original founder of the framework. And now he's doing this other framework called Armaria, which is a higher level abstraction on top of Netty. And so this talk is about like all the nuance of Armaria and what it adds above and beyond Netty. And then from 2016, this is a talk from Norman Maurer. Seems like all the good talks are in Europe, at least. But this talk was titled "One Framework to Rule Them All," which might be true, because Netty seems to be pervasive now. It's definitely still going strong. So I guess to conclude, Netty is everywhere. It's probably on your class path. You might not directly use it, but it's indirectly a transitive dependency. Netty is designed to be very extensible, so it allows you to plug in new functionality. Just in general, my opinion is Netty's awesome. There's a monthly release. They have a great like cadence. Each release has been more stable than the last. At Netflix, we would just typically pick up the new release the same week that it came out, and then we'd roll it to prod. It's one of the few libraries where like I really do trust the owners of it. They raise the bar on every release. That's been my experience. It's rare that there's like a regression. I mean, I'm not saying regressions don't happen, but it's not a normal thing. Yeah. So I don't know. I take some questions. Oh, go ahead.
Just curious, and I don't know if this is within your purview of information, but when the canary issue happened with JDK 21, did the Netty team ever decide to maybe proactively test like preview builds or RC builds of JDK 21 or future JDKs, I should say?
Oh, that's a good question. So did the Netty team are they testing preview releases of the next JDK? They're using GitHub Actions to execute like their test suite. I don't know that they've put JDK 22 in their build matrix. I'm not sure. I haven't even looked. I haven't even tried it. I can say that I have like a little demo app that I wrote that I ran on JDK 22 with the latest Netty code, and it worked. Yeah. There's a lot of open source projects will have a build matrix, and a lot of them will start to add like the EA JDKs to stay ahead of the curve to ensure that like things are stable before those JDKs get finalized. I haven't been looking at the build matrix on Netty, but they're not doing JDK 22. I may open a pull request.
Leak detection, other than finding the object that you're referencing it that creates the leak, or you're stuck with it rot. Basically, the only thing you can do is restart the server, right? Or are there other options to consider if you're trying to triage a leak and rot?
Like in the Netty wiki, they actually say like, if you can't reproduce it locally and you're just like pulling your hair out, maybe you could run a production canary on a single node, turn on paranoid mode, paranoid detector, and then hopefully that'll get you enough detail to if it reproduces on that box, you'll have that extra information from the paranoid detector. You wouldn't want to roll out paranoid mode to your whole like production cluster, but yeah, I mean, you could do it on one node, and that might be, yeah, best bet.
Well, I mean, that's detection, but I'm saying you butt in the leak, you basically down so restart the thing. I mean, or are there other options?
Yeah, I mean, yeah, you'd have to recycle your server instances more frequently. Or like you use a bigger server instance that has like twice as much memory, and then you won't fall down as fast. I can't think of any other options. Thank you. All right, well, I'll stick around. Oh, wait, one question in the back.
Yeah, so I wanted to know how that you handles errors and in order to ensure fault tolerance in network communications.
How does Netty handle errors?
Yeah.
It might be hard for me to answer that, but so in Netty, like when you have a channel handler, there's like a channel handler is like a way for in the Netty model, there's like it's an event-driven framework, so there's like callbacks. And so like Netty will call one of your methods. It'll be like called exception caught or something. And Netty can like tell your handler that something went wrong through a callback method. And you know, in some cases, you know, at least with like the Zuul application, I mean, there are custom handlers in that app that are explicitly there just to handle like edge cases. So like you know, with the WebSocket connect, like Zuul uses WebSocket connections, and maybe you're writing some data out on a WebSocket, and then something weird happens, and Netty's going to notify you through a callback. And that's the typical way that would happen. Cool. I'll stick around if anyone wants to chat one-on-one. That'd be great. Thank you.
Thank you. And right now, I think we have our JetBrains raffle, and I think Josh is going to run the wheel of names. So thank you, Sean.